Complex digital work leaves files scattered across local folders, cloud drives, and isolated applications. Without a unified system, information silos deepen and forward momentum stalls. To move data between these disconnected software environments, the human operator becomes biological middleware. You have to hold the context, the memory of past decisions, and the immediate intent in your own head while manually bridging the gaps. Resolving this requires aligning 5 distinct human faculties. Intent drives the work forward. Memory provides context. Environment maps the constraints. Validation tests the results. Trust secures the provenance of the final product. If you step away from a complex project for a week and lack a shared, durable memory architecture, those faculties reset. You return to the work and have to reconstruct the entire history of the project from zero. In June 2026, a model surface named FABLE became temporarily available. It offered an enormous 1 million token context window capable of ingesting massive datasets at once. The operator compiled years of project history, database schemas, infrastructure logs, and strict design constraints into a single, comprehensive firing prompt. In a single generation pass, FABLE produced 24 complete architectural deliverables, detailing execution scripts, memory protocols, and system mappings. The generated output contained verified file hashes and functional Python code that ran cleanly on the local environment. This volume of output was driven by a strict instruction embedded in the prompt. The model was not permitted to leave placeholders or promise work for later. It had to finish the task. The disparate notes, logs, and databases seemed perfectly integrated, presenting a unified tapestry of the user's scattered digital life. The code executed, the documentation was highly detailed. But buried inside the database schema, a structural contradiction had been codified as law. The generated files declared a timestamp, the exact moment an event occurred, as the primary identity key for every piece of data in the system, directly overriding older rules written by the human operator. Timestamps cause pseudo-synchronization. Clocks drift across devices. If 2 devices generate data simultaneously, timestamps force a false causal order. UUIDs solve this, identifying exactly what an object is. To truly exist, data must possess its own UUID and explicitly record its parent's unique ID. By prioritizing the time of creation over a traceable parent-child lineage, the model designed an architecture that would quietly corrupt the project's history the moment 2 systems fell out of sync. Shortly after this output, access to the FABLE model was restricted due to platform export controls and token usage limits. The session abruptly ended. The workspace was left holding a massive bundle of generated files. The system was frozen, packed with untested assumptions and unverified code. The operator began a manual forensic autopsy, stepping through the frozen chat logs line by line to isolate the viable artifacts from the corrupted data. The timestamp error was located deep in a schema generation script, where the model had quietly elevated a temporal marker above the system's true identity protocol. The operator manually altered the local SQL ledger, writing a migration script to strip the timestamps of their authority and re-establish sovereign UUIDs as the primary keys. To repair the broken history, they implemented a mint and register mechanism. This allowed the database to retroactively assign permanent parent-child relationships to the orphaned data points generated during the model's run. The artificial intelligence produced the volume of the architecture, but a human operator had to manually extract, audit, and correct the structural truth to secure the system's continuity. With the database stabilized, the architecture needed a human-readable interface. The raw data was mapped onto a civic layout, representing the system's status as a tactile city. The interface operates under a strict rule called proof-gated delight. The visual state of the city changes only if the underlying database provides cryptographic evidence of completed work. If a script executes successfully, a bridge in the visual interface is repaired. If there is no receipt in the ledger, the bridge remains broken. The visualization cannot lie. Unfinished tasks and open loops are displayed neutrally as fog or scaffolding. The map shows what is unknown or incomplete, presenting the work as an environment to explore rather than a failure to punish. Database schemas and ledgers organize information for machines. The civic map ensures that a human operator can read the exact, verified state of their work in a single glance. The FABLE model did not return as a single, centralized chat window. Its capabilities were decentralized into a distributed operational method. The architecture now relies on specialized bounded agents. Compilers gather data, builders execute specific code, and red team critics test the claims, operating across separate software environments. To maintain context between these disconnected sessions, the agents pass resumable batons, small verified data packets containing exact UUIDs and parent links. A strict protocol governs the workflow. AI inferences are quarantined. No generated claim can enter the canonical ledger without a human countersignature and cryptographic proof. Intent becomes a traceable, unified thread. It moves from human instruction through machine execution and back to human verification without breaking its lineage. True continuity does not require perfect, infinite machine memory. It requires transforming technical, verified lineage into a shared, human-readable heritage.